Hi everyone, this is Amy from Pinnacle Coaching. So today what I've got for you is one of the first videos under the Study With Me series. So I'm going to try this for the over the next couple of weeks to go through selected topics, especially in that new syllabus in the Year 11 Mathematics and Extension 1 areas. And hopefully this will help you to prepare for the upcoming preliminary exams. If you have any questions and comments, make sure you leave it down below. Let's get straight into it. All right, so today, actually I should come back here. So before I get into it, I'm going to focus on an area called photographs. So this is part of the new Extension 1 syllabus. A lot of the content in here is a little bit more advanced and it builds on your knowledge from functions. And a lot of that stuff have been brought down from extension too. So through my teaching at the college, I sort of see that a lot of students are struggling with this topic. So I thought I'll tackle this one first. And if you have any questions or make sure you get in touch with me. I know this topic's a little bit tough. So I try to break it down to the different types of shifts and transformations, and hopefully it all makes sense. All right, let's get straight into it. All right, so the first thing we want to look at is shifting left and right. So generally speaking, so let's say this function is y is equals to fx. So let's say we have y is equals to fx minus 2. So generally, if you have a function and replace the x with x minus 2, that one is right by 2 units. All right, so meaning you take all the x coordinates on the graph and move it to the right. Okay, so if you, for example, take this guy here, move that to the right by 2 is about 4. Move that to the right by 2. Move that to the right by 2 is now here. So I'm going to try to draw this. Okay, and that point is now 3 plus 2, 5, 1. All right, so that would be the graph of y is equal to fx minus 2. All right, so you basically take all the critical points and move it to the right by 2. Now, what if, let's say I have y is equal to fx plus 1. Replacing x with x plus 1 moves everything to the left this time by 1. So you take the same thing with the same critical points and just move it across to the left by 1. All right, so this point is now at 0. 2 is now at 1. All right, so I'm going to try to draw this. This is a lot harder to draw on the computer. It's much easier to do it on the on paper, but hopefully it all makes sense. All right, so key point, right? X plus something is left. X minus something is to the right. That's it. As long as you know that, you should know how to shift left and right. All right, let's take a look at up and down. What happens if we want to shift up and down? All right, so let's say again that's y equals to f of x. If you go y equals to fx plus 1, you move it up by 1. Or alternatively, I just always want to give you an alternative because previously left-right is an adjustment to x. Technically, up-down is an adjustment to y value because what you're actually doing is replacing y with y minus 1. That's actually how you get the fx plus 1, right? If you replace y with y with y minus 1, that's the effect of shifting up by 1. Or in other words, it's equivalent to fx plus 1. All right, so what you do is this time it's an adjustment to the y values. You take all the y values, add 1 to it. Okay, so let's see. So this is at y is 0, so y is now 1. Y is minus 1, so now it's at 0. This one's at 2. I'm just going to try to draw this first. Alright, so this point is now at 3, 2. Alright, so that would be y is equals to f of x plus 1. Okay, so I might do the other one in a different color. Alright, so let's say I have y equals to f of x minus 2. This time it's down by 2. Now that's equivalent to an adjustment of y plus 2. That's what this is, where this is coming from. It's adjusting the y value, and this time it's down by 2. So you take all the y values of the coordinates and just move it down by 2. And that one's at minus 2. Alright, so you kind of get the gist of this. So let me just draw this. Alright, so something like that. And that 3, 1 is now at 3, negative 1. Yeah, 1 minus 2 is negative 1. Alright, so that's the green one. So I think I color coded. It's just easier for you to see. Alright, so to summarize, left, right, it's an adjustment to x. Up, down is an adjustment to y. So you can see if it's fx plus 1, it's up by 1. If it's fx minus 2, it's down by 2. Alright, so that's it. How about reflections? So reflections, let's say, again, this is y is equals to f of x. If you want to draw f of minus x, what that is flipping all your x values, right? What is 2 is now negative 2. So the effect is reflection across the y-axis. So reflection across the y-axis. So that's all you do. Right? So I'm just going to try to mirror this across. And then this point is now here. So I'm going to try to draw this. Alright, so something like that. And this point here, 3, it's now at negative 3, 1. Alright, so that's it. And then the other one, let's use a different color. So this time, if I have minus f of x, which is equivalent to adjusting. So again, I'll do it in blue. This is equivalent to replacing y with minus y. All right, it's an adjustment to y. Okay, so all your positive y values is now a negative y value. So everything gets reflected across the x-axis this time. So this point is now up here. And then we'll just mirror the graph. Right, so let me move my face so you can see that. 3 minus 1. Alright, so that's your y is minus f of x. Or in other words, minus y is equals to f of x. Right, so to summarize, reflection across the y-axis if it's minus x. Reflection across the x-axis if it's minus f of x. Right, so those 3 transformations so far, they are part of the 2-unit course, right? So as a 2-unit student, that's the bare minimum you need to know from a transformation perspective. And the idea here is if you know any graph, let's say a parabola y equals x squared, you should be able to apply these transformation techniques and work out what the new graph looks like. All right, so moving on to more the extension content. So this time, let's explore the effect of applying absolute brackets to different places in the function. So again, let's start with f of x. What happens if we apply absolute brackets across the entire function? So what that does is it makes everything negative y positive, right? It just flips everything below the x-axis above the x-axis. So let me show you. right? So this point is now at 1, 1. And this part, which is originally positive, will stay. Right, so that part stays the same. All right, so this red graph will be absolute f of x. All right, what if we have y equals to f absolute x? So this time the absolute is only applicable to the x component. Okay, what does that do? That means whenever your x value is negative, so let's say this point here, right? Let's say that's about -1, yeah? What that does is, if you think about that, f absolute -1 becomes the same as f of 1. But what is f of 1? F of 1 is -1. So the effect of that is basically chopping off, clean out everything to the left of the y-axis and just reflect that across. So this original part will stay, right? So I'm going to trace over it just to show you that's part of the new graph as well, okay? And then you now need to mirror that. Let me just do the points first. All right, so something like that. Oops. That's better, -2, and then this point will be -3, 1. All right, so this red one, this W look thing, is absolute x. All right, what if we now place the absolute around the y component? So this time it has the effect of deleting everything that is negative y. So everything below the x-axis has to go, right? So boom, 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 that disappears. I'll use blue to draw the new graph. And everything above the x-axis stays. Okay, so this bit stays. And it gets reflected across as well. All right, so basically it's similar to the previous one. It's just now it's happening on the y values. And then finally, let's see what happens when you combine a few of these. Let's say, for example, we have f of absolute x, and then we put an absolute bracket around that as well. Okay, so do it in stages. So let's start with the absolute x itself. So we've already done that previously. It's just the right part and then the left part. Right, so that's 1, -1, -2, -3, 1. Okay, so that's what we've drawn previously. Now I'm going to use a different color. I'm going to use green. Okay, so this graph here, I'll just circle it. Now you take this function and apply absolute, which flips everything negative across, right? The absolute outside of f of x have that effect. So I need to reflect that across. So it's not very symmetrical, but I'm sure you know what I mean. And then obviously the bits that were positive to begin with stays. All right. So that is it. So to summarize, let's go back. To summarize, absolute on the entire function reflects everything negative across to the positive side, so above the x-axis. If it's actually inside on the x only, you chop off everything left of y-axis and reflect everything right of y-axis to the left. If it's only to the y, then you chop off everything that is below the x-axis and then reflect everything above the x-axis below. And then finally, a combination graph like this one, you just apply the two techniques in stages. So in this one, the first technique is absolute x. So everything left disappears, reflect to the right. So that's the red one. And then the green one is what happens if you apply the absolute on the entire function, which deletes everything below and flips it across to the positive side. All right, so with absolute brackets, I think if you're struggling, the easiest way just to remember what each of them do, yeah, what happens when you apply the absolute bracket. It's a very standard procedure. You delete this, reflect this, yeah. Or just think about what happens to the numbers, like what I showed you before. I think that's the easiest way to go about it. All right, so next one, reciprocal functions. Reciprocal functions often quite challenging for a lot of people. Let me see. Yes, I wanted to get rid of that. Okay, so it's very challenging for a lot of people because it's actually quite hard to conceptualize. So this is my take, right? Let's say I want you to draw one on fx. Yeah, this is the fx function. Basically, what is fx? Let's think about that. Fx is the y value on this original graph. So whenever you're drawing a reciprocal function, right? If you're a little stuck, just pull out your calculator, read the y value, and think what 1 over that y value is. Yeah, that's how I teach all my students. If you're really struggling, eventually, if you do it enough times, you'll get the hang of this. But to start with, right? Let's start with 0. So these are y, this is 0, 0, and 2, 0, right? They both have a y value 0, but 1 on 0 is undefined. So generally speaking, on the reciprocal function, you've basically got vertical asymptotes there. Okay. How about this point? This one has a y value of -1. What's 1 over -1? It's still -1. Okay, stays that point. Let's say here, so this point, it's about -1/2, right? If you think about it, this is about -1/2. What's 1 over -1/2? About -2. Right? So you kind of get the point. So this is about -1/4. Y is -1/4. So 1 over -1/4 is about 4. So it's about down here. Okay, same here. That's about -1/2. So it's about -2, -4, etc. So what you end up with is something like this. Okay, approaching the asymptotes at x equals 2 and x equals to 0. All right. So let's do this point. That's 1. Y is 1. So 1 over 1 is still 1. Let's say this is about 1/2. Yeah? So this is about 1/2. 1 on 1/2 is about 2. Right? 1 on 1/4 is about 4. So you kind of get the gist here. And then, now this thing goes off to infinity. What's 1 on infinity is going to go towards 0. Okay, or you just keep testing numbers, right? So same here. This is about -1, so let's say it stays there. Yeah, this is about -1/2, so -1/2 is about -2. So this one again goes towards negative infinity. So the original function goes towards negative infinity. 1 on infinity is 0. All right, so that's about right. So there is actually a horizontal asymptote at y equals 0. All right, so I hope that makes sense. So to summarize, usually x-intercepts are vertical asymptotes. Whenever the y value is 1 or -1, they stay the same place. If you have a number that's below 1, generally you're going higher and higher and higher. If it's a large value originally, you're going to go lower and lower and lower and approaching 0. Okay? And generally around the asymptotes, you expect it to go to infinity. That's what you see on the graph here. All right, so what is another challenging one? Square root. So, all right, I actually think the square root function is actually a lot easier compared to the reciprocal function. So first of all, when it comes to square root of function, you can't square root a negative number. So you can pretty much ignore everything below the x-axis because fx is negative, right? Ignore. So we're only looking at this part, okay? So root 0 is 0. root 1 is 1. Now, what you will find is, let's say root 0.5. You'll find that root 0.5 is actually higher than 0.5. I think from memory it's about 0.7. So you can double check your calculator. So it actually ends up slightly higher. So generally the behavior switches over around 1, okay? Root 2, for example, so let's say this is about 2, so this is the original function, let's say. Yeah, this is about 2, for example. Root 2 is about 1.4. So 1.4 is actually about here. Okay, so it's going to end up below. So this is going to look something like this. Now, sometimes as an extension of this, you may be asked to graph y squared is equals to fx. Y squared equals to fx is actually the same as this thing, because what happens is that's equivalent to the plus minus square root of f of x. So the only difference is you also have to draw the negative branch. Or in other words, you just reflect that across. So this blue one, including the original one, yeah, will be y squared equals to f of x together. Okay? All right, so to summarize, how do you draw a square root function? Very simple. Ignore everything below the x-axis. Root 0 is 0. Root 1 is 1. If it's below 1, the new graph should be higher than the original function. If it's above 1, like these guys here, it should be below the original function. So you can see it's below the original function. Okay, again, use your calculator to work out these numbers if you have to. All right, so I'm also going to quickly go through 2 more examples where I think it's not strictly in the new syllabus, but I've seen a lot of selective schools especially still teach it anyways. It was in the original extension 2 syllabus. So why not take a look at it? It's not too hard to do them anyways. All right, so what happens if we square? So if you have a function and you square it, basically all your y values get squared. So fx is the y value of the original function, and you need to square everything. Okay, so let's go through this process. So 0 squared is still 0. Minus 1 squared is now at 1. 0 squared is still 0. 1 squared is still 1. So more or less, it kind of looks like this. It ends up having the effect of, so let me actually do it in stages. So I'm going to reflect the original function across first, just as a point of reference. Okay, so I've just in blue reflected the original function across. Okay, so the effect of that is whenever, let's say a half, right? About a half. What happens if you square a half? A half squared is a quarter, so you end up actually lower, yeah, than the original function. So same with this point roughly is there. Okay, so I'm just going to draw that. Sorry, let's just draw this a bit better so you can see. Okay, it's more like that. Okay, so that one didn't draw very well as a turning point. Yeah. Okay, so what happens is anything below 1, when you square it, it's going to end up with a smaller number. So you see how I try to illustrate this. The red one is actually below the blue one. And once it switches over 1, what happens to 2 squared? 2 squared is 4. It becomes higher. Okay, so you can see this is above the original function. Okay, and another important thing is probably not very obvious here, but I'll use a different color. The x-intercepts always end up being turning points. Now, if you're wondering why, and you've done calculus, maybe look at the calculus of a square function, and you can probably figure out why that happens. Yeah, so all the x-intercepts becomes turning points when you square a function. If you're squaring something below 1, you end up with a smaller number. If you're squaring something above 1, you end up with a bigger number. And if you're squaring 1, you still get 1. And when you square a negative number, it's positive, so there is nothing negative about the square function. Everything that was negative is now positive. So finally, what I've got for you is a composite function. So composite function is actually kind of complicated, but the best way to sort of go about it is, again, think about the adjustment to the y value. So let's have a look at this example. Let's say this is f of x, and I want you to graph y is equal to e f of x. So that means all the y values you see on this function, you need to attach a base e to it, okay? So let's map out the point. So I'm just going to do the original point. So x, let's have a look at this. So x is 0, function, exponential function. Okay, so original function is 0. I'm just going to map out the points. So 1 is at -1, 2 is at 0, 3 is at 1. Okay, so the new values is e0, e to the power of -1, so e to the power of 0, e to the power of 1, e to the power of all these y value numbers you see. So that's 1, e to the power of -1, 1, and e. E is about 2.71. E to the power of -1 is something below 1. I don't remember off the top of my head. It's a small number. Okay, you can check that with the calculator. All right, so I'm just going to map that, right? So 0 is at 1. 1 is e to the -1, so it's about there. 2 is at 1 again. And 3 is E. E is 2.71, so it's about there, about 3, yeah, 3E. Okay, so I can pretty much join them up first, and then I'll explain. That's good enough. Okay. So then, from here, as x approaches -infinity, you can see the original function is going towards -infinity as well, right? So if you go down here, it's going to go all the way down here. But what happens if you have a large negative number? It actually approaches 0. Yeah, if you think about what the exponential function looks like, so this is what an exponential function looks like. When it's negative, it's actually approaching 0. So we are going to reflect this asymptote, okay, at y is equals to 0. All right, so that's composite function. So if you have a calculator with you, just try to do this yourself, right? Just take all the y value, shove it into the calculator as e to the power of whatever y value you see, and you pretty much have a map of your new function. All right, so that is it. So the last two, so the squared function and the composite function, technically not strictly inside the new extension 1 syllabus, but it's good to be aware of how they graph it. And if you're in a selective school, most likely you may have come across some of these functions as well. All right, so that's it for this particular video. Now, I would love to hear feedback and comments. So if there are any topics you would like me to tackle in the next couple of weeks, so I'll try to do at least 2 videos a week leading up to the preliminary exam. So in about a month, yeah, preliminary exams about a month. So it's good to hear your thoughts, your feedback. What do you need help with? You can either go to our Facebook page, Pinnacle Coaching College. You can message us on our page. You can email us. You can go to our website and contact us. Or even just simply leave a comment down below so that I know what to do next. But anyways, I hope this has helped you. And if you do have any questions at all, feel free to reach out. Bye for now.